Hi and welcome to another video from Crumpled Underfoot. This is the third in the series, Staad Basics. If you happen to miss the first and the second videos, I put the respective links below for you to check them out. Today, we will continue from where we left off last time. Here's our model. I had all the numbers changed and I also worked with the groups with the following convention. So our main objective for today is for you to complete the model and to run the analysis. We will begin by defining the materials and section properties. For this example, let's use reinforced concrete. As a side note, we can also use the same structure geometry later on once we work on another example such as a steel building. So Staad by default contains certain material properties such as concrete and steel. In this case, there is no need for us to create concrete properties unless we have some special requirements. By clicking the General tab, found here on the left side of the workspace, we can find the material option. And you can see here the materials which this version of Staad has by default. The next thing we want to do is to start defining the section properties under the property option. Most regular shapes such as square, rectangle, and circle could be made using the define option. On succeeding videos, we will make use of the section database, but that's only once we will deal with steel structure. For now, we stick to define option. For this example, let's use 3 rectangular sections. One for each set of main beams, secondary beams, and columns. Then I will assign them thereafter using the groups that we defined earlier. Notice there are several methods of assigning these section properties. Since we arrange the group systematically, we may easily isolate each group, just like I did, and use assign to view or assign to selected beams. The next step is to assign loads. An important node you need to remember is that all load items should be placed within load cases. I will repeat that. All load items should be placed within load cases. That means you need to define specific load cases, say dead load, before you'll be able to define load items such as self-weight, nodal loads, member loads, floor loads, etc. But prior to making any load cases, let me show you the auto-load generation feature of Staad. This can be done using the definitions option found under Load and Definitions. We have several options here, but for this example, we will try to generate seismic loads using UBC 97. As a side note, UBC 97 is one of the references of the NSCP. These parameters here should be familiar to you. Let's say our site is within Zone 4. Being a structure of ordinary occupancy, importance factor is 1. For the values of R in each direction, consider a special moment resisting frame with R equals 8.5. And so on. Now you can leave this blank, these values that have asterisks in them, because Staad can take care of them, so don't worry. The next important things here are the seismic weights, such as the self-weight, joint weights, member weights, element weights, etc. They have to be defined separately from the load cases. These weights, together with the parameters we defined earlier, would be the basis of Staad in calculating the value of the base shear. So these weights should not be mistaken with the actual load cases. Take note of the values of the coordinates here, since we will use them in defining the range of our floor load for our seismic weights, also with our load cases later on. After the seismic definition, we can begin to add load cases with the following order. First, seismic in both directions such as X and Z. Next is dead loads including self-weight and SDL. The third would be live load, and finally, the combinations. Once we have our load cases in place, we can put in specific load items inside these cases. To assign them, we can make use of the same methods we did for assigning the section properties and for the seismic weights. By the way, our earthquake cases, such as the UBC load X and Z, they do not have to be specifically assigned in every member, since Staad already calculates them based on the definition that we had earlier. Notice the value of our live load at 2.4 kilonewtons per square meter. I added 10% of this load to our seismic weight. That's why you have the value here, 0.24. The reason I'm using one-way load distribution is because of the arrangement of my floor beams. It's evident here that my load distribution is in one way. So we're done with the load items. They're all assigned. Remember that this icon here would have a question mark if that load item is not yet assigned. So we proceed with the combinations. 301 is 1.4 times the dead loads. So we'll use repeat load for that. Then we add all our dead loads and give them a factor of 1.4. Same thing for this one, but in this case we include the live load. Before we can run the analysis, we first need to specify the type of analysis to be performed. This could be done under the commands analysis, then perform analysis. Basically, we may use of no print as a standard form of static analysis. In some cases though, we may need to use other options. Personally, I use statics check. This is a simple way to verify the software's result. Then finally, we can run the analysis by clicking Analyze and then Run Analysis. It seems I forgot to input NA and NV, so we need to go back to that. Yep. These commands that I'm adding here are part of the requirement of Staad whenever you define a UBC load. I guess in other versions, these commands are already added or automatically added. But for this one, I need to add it manually. Then let's try once again. I got one warning. So Staad wants us to break those one-way loads into smaller portions, but I would just leave it at that. Then these are our results. The total weight, and then the total base shear for the UBC cases. And for statics check, we can see here the total loads and correspondingly the total reactions. So we can easily verify them using quick hand calculations whether they match the proper loading, and the total reaction. Congratulations! You can now create a basic analysis model in Staad. In the next video, we will explore the post-processing features of Staad, in which we can find specific results from our model. So stick around, and I hope you enjoyed this video. Don't forget to subscribe to stay tuned. If you learned from this video, please don't hesitate to share this and add some comments below. I also added a link of the model so you can get and study it. Thanks for watching. See you around.